In this video, we are going to learn how to solve equations involving logarithm. There are three techniques to solve equations involving logarithm. The first one is substitution. The second one is by using properties. And the third one by comparing log both sides. For the first technique, which is substitution, we will use this technique if we have the question involving different base of log. We will use properties or comparing both sides technique if we have the same base of log. So it is very important for us to check the base of our log before we solve the equation. So now we are focusing on substitution technique to solve equation involving log. Let's look at example 18. Solve log x base 5 plus 3 log 5 base x equals to 4. So from this question, we can clearly see that the first log, we have 5 as the base, and for the second log, we have x as the base. So we have different base. So that's why we're going to use substitution technique. So let's look at the solution. First, rewrite the question. Log x base 5 plus 3 log 5 base x equals to 4. So since the base are not the same, so we are going to make the base be the same. So we will change log 5 base x to base 5. So step 1 is to change the base. So log x base 5 plus 3 log 5 base 5 over log x base 5. It is easier if we change the base to a number instead of using x as the base. So that's why we change base x to base 5. Then, as we can see here, we have 3 log 5 base 5, and if we can recall from rules of logarithm, log 5 base 5 is just 1. So our equation will be log x base 5 plus 3 over log x base 5 equals to 4. Now, moving to the next step, step 2, we will simplify our equation by letting log x base 5 to a simpler variable. So let a equals to log x base 5. So wherever we have log x base 5 in our question, we will substitute it with a. So that's why we call it as substitution method. So log x base 5, a plus 3 over a equals to 4. Then step 3, we will simplify our equation and make it as quadratic form. So what we need to do now is, from equation a plus 3 over a equals to 4, we just multiply a on the left hand side and on the right hand side, so it will be a square plus 3 equals to 4a. Then just rearrange our equation so that it will be quadratic on the left hand side and 0 on the right hand side. So a squared minus 4a plus 3 equals to 0. So now we have this quadratic, and we will move to step 4. Since we have quadratic, so we will solve the quadratic. So again, to solve quadratic equation, we can simply use our calculator. So we have our quadratic here. A squared minus 4a plus 3 equals to 0. So factorize it. By using calculator, we will have a minus 3. A minus 1 equals to 0 as our factor. Then we will have a equals to 3 and a equals to 1. Then we need to remember that we don't have a in our question. We only have x, and we need to solve for x. But now we only have a. So now for step 5, we will substitute back a equals to log x base 5. Because our question, we have x, not a. So from a equals to 3, we will change it back to log x base 5 equals to 3. And a equals to 1, we will have log x base 5 equals to 1. So this is step 5. Then the last step is to change our log to index form. So why we need to change log to index? Because we want to find the value of x here. From step 5, we only have log, but now we need to find the value of x. So that's why we need to change log to index. So from log x base 5 equals to 3, we will have x equals to 5 to the power of 3, so that x is equals to 125. Okay, same as log x base 5 equals to 1. So x equals to 5 to the power of 1, x equals to 5. So we have two values of x here, x equals to 1 to 5 and x equals to 5. So don't forget to recheck to see whether both x are valid or not for our question. So to recheck our x, just simply substitute x equals to 1 to 5 and x equals to 5 into original question, which is log x base 5 plus 3 log 5 base x equals to 4. So we can verify that our answer is x equals to 1 to 5 and x equals to 5. So that's all for this video. Just follow the steps to solve equation involving log if we have the log with different base. That's all. Thank you.